So again, we're just going to take a few minutes, input the 1, 2, 3, and 4 answers, and I'm going to go over them.
Perfect.
Okay. So it looks like everybody has answered. So for question number 1, guys, we did fantastic as a group. We averaged a 79%. For question 2, we also averaged a 79. 3, we averaged a 71. And 4, we averaged a 71. So overall, I feel pretty good about that. That means that a majority of us are seeing how to get these answers and what these answers are. So I don't know if the formative told you the correct answers or not, but I am going to. The correct answer to number 1, the radius of a circle changing, was letter C. So again, the correct answer to number 1 was C. Okay, number 2, the height of the grain in a cylinder silo is increasing at a constant rate of 4 feet per minute. The correct answer here was E. The correct answer here was E. 400 pi feet cubed per minute. So again, it didn't help you in this case, but if it asks me for a rate of volume, one of the things I always do is look at my answers and look to see if they're all cubic. If the units aren't all cubic on them, then I can eliminate them. Okay, and this one, this was a calculator allowed. It said at what instant is the radius changing? So radius is changing in inches per minute. And I believe the correct answer was A. Yeah. And then number 4, you have our camera. So this ended up being a 3, 4, 5 triangle. And then you move and find and adjust the angle. And you got C. That's C. If anybody needs to see the work for those, I have that back here. I can easily send you a picture of any of those individual problems. Don't hesitate to ask. I will gladly send and share. So, the last thing I had you do was look at this free response question. A free response question is worth 9 points on the AP exam. A free response question is worth 9 points on the AP exam. So what I want you to do now, if you did this problem in pencil, get out a pen. If you did the problem in pen, take out a pencil. If you need a different colored writing utensil, I have some colored pencils. I'm going to teach you how to grade this problem as if it was being graded for an AP free response, so you can see the score you would earn out of 9. It's also going to be kind of how we go over the problem. But I think one of the best ways to learn how to do well on a free response is to learn how to score a free response. Do you want a colored pencil, different color? I mean, you can just use what you have. I just try to tell you to like switch it up so you can see like what you're changing. But if you don't want it in different color, you don't have. It just sometimes like if I grade your test, you know, usually grade it in a color other than what you're writing with, so you can see like sort of my marks. So I was trying to just tell you to like do it that way you can see your changes as you went. So it says the volume of a cone with height h and radius r is given. So this is an actual AP question from a couple years ago. So that's why I was telling you the other day in class, don't stress about memorizing the formulas, because typically if you need a formula or you need to derive it, they give it to you. So you can see in the case of this problem, they gave me volume. They also gave me h changing at -3/10. So that represented dH dt. This value here represented dH dt. And then in the diagram, they actually gave me measurements. So you had to take into account what they gave you in the picture, what they gave you in the problem, and what they gave you in words. So for part A, to find the volume, okay, I wasn't sure if I put it up there. Let's go through that answer key. I'm going to put it up on the document camera. I can't remember if I screenshotted it in there or not. So we're going to break this down into parts. So the first thing we're going to look at is part A. So in part A, they gave you 1 point if you had the volume when h was 5. So you earned your first singular point if you had the volume correct when h is 5. So if in part A, you plugged 5 into the volume formula and you got 125 pi, then you got 1 point. So I would just on your paper write +1. If you errored that, then maybe just see where, so like I would write a little +1 next to it. So you can add up all your pluses at the end. If you made an error, where did you make your mistake? Is it something you can correct? Did you mess up the relationship between height and radius? So it said find the volume, indicate units of measure. So you're going to notice it says indicate units of measure here. It says it here. That is only going to be worth 1 point overall. So if you had centimeters cubed, put like a little check mark, but you haven't earned your point yet, because the units from part A and the units from part B are going to earn you the whole point. So it's kind of like earning half a point, but they don't do half points. So if you had centimeters cubed next to that answer, you're good. Now, let's say you didn't know how to find the answer, but you knew the units. You can't just write the units and leave this blank. You would do better writing 5 centimeters cubed and hoping to get your unit points. But if you have units with no number, they won't count the units. So if you don't know how to do something but you know the units, you have to write a number, any number in the world, in front of it. Does that make sense? Okay, for part B, it said find the rate of change of volume in the water. So we're looking for the rate of change of volume. I'm looking for dV dt. Find the rate of change of water volume. When h is 5, so that means at h equals 5, so that's some of my key information. If I know h equals 5, then I can find the radius, which is half of 5, or 5 halves, and I was given dH dt from the very beginning. dH dt was -3/10. So here's what I know, and then I'm going to look for what I need. So if I need dV dt, I'm going to find the derivative of volume. So the derivative of volume is 1/4 pi h squared dH dt. Derivative of volume is 1/4 pi h squared dv dt. If you had volume as a function of just h, so no more r, then you earned yourself another point. So if you had volume in terms of just h, you earned yourself another point. If anywhere in part A or part B, you had this wrote down, you earned yourself a point. So if anywhere in part A or part B on your paper, you have r equals 1/2 h, you got a point. So at this point, we've given out 3 points. You earn another point for getting the correct answer to dv dt. So you got another point for getting a correct answer to dv dt. So this got you your point. And then your units had to match as well. So you needed to have centimeters cubed per hour here and centimeters cubed here. If you had both of those units right, give yourself another point. And actually, it looks like they gave you 2 points for dv dt. This one's from 2002. They wouldn't give you 2 points for that anymore. So you can actually put a +2 here if you had that correct. Sorry. And they also gave 1 point for writing the substitution prior to deriving. I don't think, did any of you actually try to do dv dt this way using the product rule and leaving r in? Did anybody do dv dt with r in? Because if you did, I'll explain it, but if you did not, I'm just going to keep it hidden.
I tried to do that, Ms. McBride.
Okay. So, like, Nick, this is what your area should look like. And then this part here.
Earned you a point. Okay.
And then the last part, part C, this is like the tricky part. This is the part where they're really testing your ability to apply mathematics outside of plug and shove. So it says, show the rate of change of the volume of water in the container due to evaporation directly proportional to the exposed surface area of the water. What is the constant of proportionality? So we know the derivative of volume. And we know the derivative of volume with respect to the rate of change, h. Now, we also know that the derivative of volume is surface area. So this right here represents the rate of change of volume but it also represents my surface area. So in order to get to the surface area, we're talking about the top area right here. Sorry. We're talking about the top area of that cone. So if you're looking for the rate of change with that cone or that top area of the water that's being exposed, we're going to take into account the derivative with respect to the radius now. Because I don't care about how the height is changing, I care about how the radius is changing, because the radius is the area of the exposed top. So this K value, this negative 3 over 40, that represents kind of like the proportion. And then pi r squared represents the surface area. So this right here, this is surface area, or area of a circle, pi r squared. We know that the radius with respect to the height is 2r. And then this is the rate of change of the height times the area. Therefore, the rate of change of the area of the radius is changing with respect to the rate of change of the height. So that should make sense, since this is a cone, that its width and height were both 10 over 10, then the radius is changing at the same rate the height is, which is negative 3 over 10. That is our constant of proportionality. So you got 1 for dv dt times k area. So you got 1 point kind of for any of these lines in here. Then you got 1 point for your final answer. And the last point down here, I already had you divvy these out. That's the correct units in A or B. If you got a 5, 6, or 7, that is excellent. If you got a 5, 6, or 7, you are on the right track. They do not anticipate anybody to get all 9 points. And you have to think about the fact that you're doing 6 of these, so you need to average about a 70% on each one. So 6 out of 9 is roughly 66%. So if you're averaging a 5, 6, or 7 on each of the free response questions, you are earning a 5 on the AP exam. So if you're averaging a 5, 6, or 7, you're averaging a 5 on the AP exam. Now again, this one, like I said, this is actually as old as you, right? You guys were born in 2002? Yeah. This one is a little bit older. It's just a really easy question in which you can do all parts. It's hard now to find a related rates question that's just related rates. The point divvying out on this would not be accurate to the points we would see on a future kind of AP thing. Okay? So what I want to do is go through and review now for the remainder of class. Before I release you and I have you study on your own, I want to do a quick review with you that goes over all our theorems and our vocab. So once again, go ahead and take out your devices, and we're going to pull up Kahoot. Alright, Zach's in, Trevor's in, Maddie's in. I have your screen frozen, that's why you can't see it. Caitlin Person, Chase, Tim, you guys are all in.
All right, it's down to a few of you. Okay.
If f is continuous, f is guaranteed to have a maximum value because of what theorem? F is continuous, f is guaranteed to have a maximum value because of what theorem? Okay, so the correct theorem is EVT, extreme value theorem. The extreme value theorem guarantees an absolute max or an absolute min on a continuous closed interval. MVT guarantees that the slope of the secant equals the slope of the tangent. To find the absolute value of a minimum on a closed interval, you have to evaluate what? All right, excellent. You have to evaluate both critical points and endpoints. You have to evaluate both critical points and endpoints. Critical numbers are what? Critical numbers are what? Yeah, critical numbers are when the derivative is equal to 0 or does not exist. That's when it's equal to 0 or does not exist. Great job, guys. Inflection points are Okay, that's not so great. So, inflection points are when the second derivative changes sign. So, yes, I could see where maybe some of us picked A. However, an inflection point must have a sign change. So, a critical point is where the derivative is equal to 0 does not exist. However, you have to have a sign change. It's not the first derivative, it's the second derivative. That's why it's not the green. If a function is twice differentiable, I just ran out of space. The average rate of change equals the instantaneous rate of change by what theorem? All right, MVT, good, mean value theorem. I'm hoping if you picked MTV, you just had a bout of dyslexia. It's a TV show. All right, Cooper, coming back. F is increasing when? F is increasing when? Woohoo! F prime is positive. When your derivative is positive, F is increasing. Hopefully we can get perfection here. That's okay, honey. I'll just skip you for this one. It doesn't hurt you. All right, fantastic. We got perfection. F prime is negative when the original is decreasing. Okay, there you go. Caitlin, 3 in a row. F is concave up when? Good. Okay. F is concave up. In which of the following instances? F is concave up. Okay, next, 9 in a row. Question 10. F is concave down when, and this is a second instant. F is concave down when. Perfect. FL has a relative max at x equals c when f has a relative max at x equals c when f has a relative min at x equals c when and f has a relative max at x equals c when this is the second derivative test for max or mins. Ooh, okay. So second derivative test says that if the second derivative is negative, then you have a maximum on the original. So you're looking for second derivative to be negative to have a max on the original. So kind of sad that only one of us knew that. Three players lost their answer streak. So conversely, you have a relative min when not blue this time. Yay! Okay, and then the last thing we looked at was linear approximation at x equals a. What is our formula for linear approximation? I know it. I'll tell you in a few seconds once we all answer. Whoa, okay, I guess it was on a limited time. I didn't realize. So, correct answer is green. L of x is approximately the derivative times x minus a plus f of a. Its slope, x minus x1 plus y1. If a ladder leans against a wall and slides down the wall, what are the variables? What do you need to know if a ladder is leaning against a wall and sliding down the wall? Why don't I care about the length of the ladder? Because it's 0. So it's not, I mean, at this point, I would probably give you credit for the red one. But we don't need the ladder. But yes, I wish I could have multi-selected both, sorry. I would take your red too. Okay, variables for water are volume, radius, height, because the radius and the height don't have to be changing equivalent to each other. So that's where you have to come up with your relationship between R and H and use it to find dV/dt in terms of one variable. Okay? Good job, guys. So basically for tomorrow, what I'll do is put 5, 4, and 3 bonus points on your quiz for doing well on our podium review. It will not be 1,000. He's just jealous. All right, so what we're going to do now is I have new review handouts for you. I'm also sending, and I'll post it up on the screen for you to check. So I have for you the answer key to the related rates homework. So we haven't gone over that packet from the other day, correct? No, because you guys left to go do your lab. So I'm going to share this answer packet with you. So this answer packet here, is it easier for me to put it up on the board, or do you want me to send you like a PDF copy? Okay, so I'll send the PDF copy of that. I am going to leave up 1 or 2 questions right now while I pass out the review packet for today. So here's one. And then I'll put up question number 2 because I think that one's maybe a little trickier. Oh, kind of cut off on the end. Okay, and then I really like the camera questions. So the camera question on that review packet was really nice because it led into a second question. So first you had to find how fast is the camera to the shuttle distance changing. So you found dz/dt. Then upon finding dz/dt, you went down here, and because we were struggling so much with SOHCAHTOA and just not like kind of knowing SOHCAHTOA, I set it up that you did each of the 3 parts of SOHCAHTOA. But it's also important to know that tangent is the best because it doesn't use any calculated values. So for the tangent SOHCAHTOA, this one's the best one because you didn't have to use anything we found up here in part A. So if you're selecting one, you want to select the one that doesn't involve calculated values. I was also trying to show here how you can simplify and cross out zeros when you're dividing. So you don't need that calculator to help you simplify. You can just cross out the numbers as whole units. Okay, final answer here was 1/8 feet per second. And then I feel like we never actually did a sphere, so here's all the work for a sphere. Can't quite zoom out enough. There we go. So anybody need a bathroom, stretch it out break, or are we good to keep reviewing? Okay, come back at 9:25. So, does anybody still think they need a ladder type problem? Or are we feeling okay about the ladders? So, if you want to be able to go back later and look, the answer to number 1 is dy dt equals negative 8/3 feet per second. So, just in case you try number 1 later, yes. Yes. So, like, if I wrote that as a sentence, I would say the top of the ladder is moving down the wall at a rate of 8/3 feet per second. So the minute I say down the wall, that implies the negative. Yes. Okay, number 2. The altitude of a triangle is increasing at a rate of 1 centimeter per minute, while the area of the triangle is increasing at a rate of 2 centimeters squared per minute. At what rate is the base of the triangle changing when the altitude is 10 centimeters and area is 100? Guys, altitude is a fancy word for height. Altitude is a fancy word for height. Think about when you talk about an airplane, they say the altitude of the airplane, that's the height of the airplane. So that's kind of like your H of your triangle. Here's your base of your triangle. We know area equals 1/2 base times height. We're given the area is 100, and we're given the rate of change of the area is 2. We're given the height of the triangle is 10, and the rate of change of the height is 1. At what rate is the base of the triangle changing? So we're looking for dB dt. So here's my drawing, here's my formula, what I know, and what I need to know. So in order to be able to do this, what other piece of information do I need to calculate? I need to find the base before I could find dB dt. So I'm going to use 100 equals 1/2 base times 10 to work backwards and solve for base. So it's kind of like 200 divided by 10 equals B, or B equals 20. I need that because when I take the derivative of area, it's going to be the product. So it's going to be the first, which is 1/2 B, times derivative of the second, plus the second, which is H, times derivative of the first, which is 1/2 dB dt. And then I'm going to plug in what I know, which is 2, 1/2, 20, 1, 10, 1/2, and what I'm looking for. So 1/2 of 20 is 10, 1/2 of 10 is 5. So you subtract over your 2 and your 10, and you get negative 8. Equals 5 dB dt, or dB dt equals negative 8 fifths. And our units are centimeters per minute. So what that means is as the triangle is getting taller, the base is getting smaller. So the base is shrinking at a rate of 8/5 centimeters per minute. Okay, number 3, the farmer and the 4 pens. So we've done one like this too. So if you need it, the answer is 14,062.5 feet squared. We already went over the homework question from the book on that. So I think we should be okay. There are some other review questions I'd rather see. And again, I have an answer key for 1, 3, etc. So if you get to these or you want to see them, I have photos of all of them. Okay, number 4, maybe I'll just set up 4 with you. So it says find the dimensions of a rectangle with area. So we know we're talking about a rectangle. We know we're given area. We want perimeter to be shrunk. So perimeter is 2 length, 2 width. So you want the perimeter to be minimized. So area is length times width. So you're going to have to come up with a relationship relating area to length or width and plugging in. I really hate having L's, so I'm going to substitute in for L. So I'm going to say L is equal to 1,000 over W, so that in my perimeter formula, I can get rid of L. And then you would simply derive this, find the zeros of your derivative, and you would get that W equals 10 square roots of 10. And then what's nice is when you plug that into L, it's also 10 square roots of 10. And those would both be in meters. So this is section 4.4. This is optimization. Okay, question number 5. Question number 5 goes all the way back to the beginning. This takes us back to section 4.1 or 2. I believe 4.1 was EVT. So 5 would take you all the way back to EVT. So it says find the absolute. The minute I see absolute and I see an interval, I'm thinking, okay, now what's tricky about this interval is it's not closed. So you have to be careful checking your endpoints. We can't really check one as an endpoint. So anytime we're looking for an absolute max or a min in general, we're taking our derivative. So that would be 2/5 x to the negative 3/5. This one has a little calculator symbol next to it. So the remaining parts of the problem could be done on your calculator. What you would need to show is the derivative. And then you want to create your candidates test based on that derivative. So you would go over here to your calculator. You would type in 2/5 x to your negative 3/5. And then I would change my window, since it's -3 to 1, I would change my window to -5 to 2. What we'll notice is that there is a point at which the derivative does not exist. That is at x equals 0. So f prime of x does not exist at x equals 0. That should make sense because this is really the equivalent of 2 over 5x to the 3/5, which would mean that f prime of x does not exist at x equals 0. So my candidates test says that I have to look at the beginning, which is -3. I have to look at 0. And then I can look at 1, knowing we get infinitely close to 1, but never actually hit 1. Once again, since this is a calculator question, now remember I put the derivative in my calculator. You could put the original in your calculator. And then go to your table and input -3, 0, and 1 to find those values. We are asked for the absolute the absolute max. So we'll notice that the highest point on here is at -3. So this is my absolute max. And the reason is because the y value is the highest among my critical points. And then my lowest, or my absolute min, is at 0, 0. And again, for the same reason, because it is the lowest among the CPs and NPs. Okay, number 6. 6 is a review of MVT. So the mean value theorem says that if we had a point it basically says that the slope of the tan equals the slope of the secant at a point C. If f is continuous and differentiable on the interval given. So we're given the interval -3 to -2/3. The only condition on this graph that doesn't exist is 0. 0 isn't included in my interval, therefore it's continuous and differentiable. So we find f prime of x. So this is kind of like -1x to the -1. So its derivative would be a negative times a negative, which is a positive. Subtract a new point away. So my derivative is 1 over x squared. The slope of the secant is f of -2/3 minus f of -3 all over -2/3 minus a -3. So that's like -1 over -2/3 minus -1 over -3. And then 3 minus 2/3 is really the same as 2 and 1/3. 1/3. So we kind of clean all this up. A negative over a negative is a positive. Negative over a negative is a positive. And 1 over 2/3 is really the same as 3/2 minus 1/3. And 2 1/3 is really the same as 7/3. So you need a common denominator to subtract. So you get 9/6 minus 2/6, which is 7/6 over 7/3. So you multiply by your reciprocal, and you get 1/2. So that represents the slope of the secant. So we need the slope of the secant to equal the slope of the tangent. Well, the slope of the tangent is represented by the derivative. So I need 1 over x squared to equal 1 over 1/2. So I need x to equal plus or minus the square root of 2. However, my answer is only the negative square root of 2 because the positive wouldn't be included on my initial given interval. So again, the positive square root of 2 would be outside the initial given interval. So by MBT, the slope of the sand equals the slope of the secant when x equals negative root 2. Okay, in chapter 4, we also talked about increasing and decreasing. So that's where we had our big table of values. So you would find f prime of x. You would find f double prime of x. You would find your zeros of the derivatives. Okay, so you'd have 2x minus 7, 6x to the 5th minus, or plus 5 rather, making my critical points 7/2 and negative 5 over 6. And then over here, you'd get 32 equals 24, or x equals 32 over 24, which reduces to 4/3. So those are considered our critical points. In order to find increase and decrease, as well as concave up, concave down, and points of inflection, you would have to find the sign of what's happening around them. So here, pretty easy, plug in 0, you get a negative, plug in 5, 10, etc., you get a positive. So concave down, concave up, and that makes 4/3 a POI. That makes 4/3 a POI. Over here, 0. Plug it into the original just because that's easiest in my opinion. You get a negative. So 7/2 is like 3.5, so maybe I plug in 5. So 6 times 5 plus 5 is positive. 2 times 5 is 10. 10 minus 7 is positive. 2 positives make a positive. This is just shy of 1, so I'd plug in -1. So you get -2 and -7, which is -9. So a negative. -6 plus 5 is also a negative. Negative times a negative is a positive. So this goes increase, decrease, increase, which means you have a max and a min. These are just relative maxes and mins because we have an open interval, and this is an odd function, which means it's increasing or decreasing without bounds. So we don't have an absolute. These are locals. Okay, number 9. Number 9 is a linear approximation. So I want to approximate 8.1 to the 2/3. So what that means is you kind of need to figure out, okay, what is my function? So if I want to approximate 8.1 to the 2/3, my function is 2/3. If I'm trying to approximate 8.1, the nice cube root below 8.1 is 8. So I'm going to say my a value is 8, which would make my x 8.1. So we're looking for L of 8.1. And then it's your f of a, so it'd be f of 8 minus f prime of 8 times x, which is 8.1 minus 8. So that's everything sort of plugged into your L of x formula. So that means I need to know what is f of 8 and what is f prime of 8. So the cube root of 8 is 2. 2 squared is 4. You could have also said 8 squared is 64, and the cube root of 64 is also 4. F prime of x is 2/3 x to the negative 1/3. So f prime of 8 is 2/3. And you have a cube root of 8 down below. So you get 2 over 3 times 2, or 1/3. So it's 4 minus 1/3, and that would be 0.1 or 1/10, which is 4 minus 1/30th. If you use the calculator, that's like 4 point something. Okay. Sorry. There should all be positive. Sorry. It's f of x plus a minus. I just missed my tick mark. Sorry. Should be a plus. And then the last part is graph sketching. So you're given f of 1 equals 3. we're given that f prime of x is positive when x is greater than 1. So what that means is that f is increasing. Here, f is decreasing. So if my graph goes from increasing to decreasing, on the original, that makes this point right here a rho max. So what that tells me is that I need my graph to reach that point, but then go up and come back down. The second derivative is positive always. So the second derivative is positive always. Sorry, I wrote max because I read that as x less than 1. It's x greater than 1. So when I go to draw this in, it'll look like that, making it a min. Because that's for x greater than 1, increase, x less than 1, decrease, and we have a nice little concave up. Okay, that literally hits on every key section. So 4.6 is related rates. That was 1 and 2. 4.4 is optimization. That's questions 3 and 4. 4.3 is absolute max and or increase decrease. So that was 7. 4.1 and 4.2 were EVT and MVT. So 5 and 6. And curve sketching is part of 4.3. 4.5 was number 9. Your test tomorrow will assess you on similar types of questions, working through one of each of those problem sets.